There's a new object in our solar system that came from far away. And again, there are speculations that it might be alien technology. Yes, I know what you think, it probably isn't, but I think we need to be open-minded about this. I'm convinced that there is intelligent life out there, and that they send probes to other solar systems seems very plausible to me. It'd be the potentially biggest and maybe final mistake that our species can make to not take this possibility seriously. So let's have a look. The new interstellar object was discovered on July 1st by the Atlas Survey Telescope in Chile. It's been named 3I Atlas, and it's only the third confirmed interstellar object ever. It's on a path through our solar system on a hyperbolic trajectory at about 66 kilometers per second. It'll make its closest approach to the Sun in late October and then head out again, unless it stops by and asks to speak to our manager. A certain Harvard astronomer by the name of Avi Loeb, together with some colleagues, published a paper on the archive in which they hypothesize that this object could be technological and possibly hostile, which is also what I said the other day as we were inspecting our fridge content. As one can expect, this idea quickly spread all over the popular science media. Avi Loeb also went to complain about Wikipedia gatekeepers, and that when the details of 3I Atlas were summarized on Wikipedia a few days after its discovery, the editors of that entry omitted any reference to anomalies right after deleting "Trust Me Bro" as a quoted source. For context, Avi Loeb also previously claimed that the interstellar object Oumuamua from 2017 was alien tech, which turned out to be wrong, and that he'd found alien tech at the bottom of the ocean, which also turned out to be wrong. So, somewhat unsurprisingly, now no one's listening. Let's not forget that in the fable of the boy who cried wolf, the wolf eventually does come to eat the sheep. So let's look at what Loeb is saying. Concretely, the anomalies he says should raise eyebrows are that, first, the object's on a near-ideal exploration path through the solar system. It comes in at almost the same plane as most of the planets and will in one go get close to Jupiter, Mars and Venus. Then again, well, that could be just coincidence. Second, Loeb and his colleagues say the object's very unlikely to be an asteroid because it looks quite large, and an asteroid so large is unlikely to make it into interstellar space and into another solar system. The currently best explanation of astronomers is that it's a comet with a big glow around it. But Loeb points out the glow doesn't fit that of comets. It seems to be missing spectral lines that you'd expect from gas emission. So he asks, well, if it's not an asteroid and not a comet, then what is it? Then again, astronomers point out the spectral lines might be obscured by dust, and it's just a comet after all. Dust, it turns out, is a very versatile explanation. It's basically the dog ate my homework of astronomy. Third, Loeb points out that the path of the object's almost perfect for the purpose of potentially staying in the solar system. That'd only take a small propulsion burst upon its closest approach to the Sun, and that'd put it into a stable orbit around the Sun. Then again, well, it could be coincidence. So, as you can see, the evidence that the object is an alien probe is in all fairness weak. Though, of course, the situation could change at any time. And I think that Avi Loeb is making good points when he says that we need to be better prepared for the possibility that one day it's not a fire drill, but really an alien probe, and that we should have intercept missions ready to go to have a closer look. However, he seems to be a little too eager to feed journalists with alien quotes, and that has alienated a lot of his colleagues. Loeb is also highly critical of research in the foundations of physics overall. In a recent blog post, he writes that the physics community became too dogmatic and risk-averse about the directions worth pursuing. Taking the wrong mainstream paths and not exploring alternatives brings the community to scientific dead ends, rich in mathematical gymnastics, but with no experimental support. That's of course entirely correct, but it won't have made him many friends. So the bottom line is, there's no good reason to think the object's alien tech. We're just watching a fast-moving, glowing object that defies categorization and might be hostile. But no worries, we've got it covered with blog posts. Did we misunderstand mass extinction? For decades, scientists have treated them as much as a reset button in which the record is wiped clean and the fittest survivors take over, like rebooting evolution and hoping the next version doesn't install too many spiders. But a new study says that's not how it works. Mass extinctions aren't the big reset we think they are. And that has consequences for how we think about ecosystems today. Paleontologists speak of a mass extinction when at least 3/4 of all species disappear within a geologically short interval, roughly 2 million years or less. That threshold has been crossed 5 times in the last 500 million years, and each of these 5 mass extinctions changed the course of evolution, clearing out dominant groups and making space for others to rise. Also, we thought. The standard story says that after a mass extinction, ecosystems rebuild themselves from the survivors. Those lucky few set the direction for the future, and that the new species evolve to fill in the gaps, and that today's ecosystems still reflect the shape of those ancient evolutionary bottlenecks. But a new paper that just appeared says the evidence speaks against it. It's not how it works. The researchers focused on the most famous of the 5 extinctions, the one that ended the Cretaceous period 66 million years ago. That's the one when a large asteroid struck Earth and wiped out the dinosaurs, except for those that we've turned into chicken nuggets. But they didn't look at dinosaurs. They looked at clams, mussels, and other marine animals that live on or in the seafloor. Yeah, I know, not the most exciting stuff ever, but bear with me. The point is, there were a lot of those species, therefore a lot of data. They classified these species by their ecological role, how they fed, how they moved, and where they lived. For example, whether it was a stationary filter feeder buried in sand, or a mobile grazer crawling across rocks, or one of those overachieving clams that does both, has a podcast and thinks the ocean floor is just a phase. They identified 37 such roles and assigned them to the species. Then they looked at who survived. The extinction was, as expected, devastating. About 60% of the marine life forms disappeared. But the surprising thing is that only 2 of the 37 roles vanished. Even the rare roles mostly made it through. If the extinction had been more or less random, this would have been extremely unlikely. The researchers ran thousands of computer simulations of random extinctions, and almost everyone wiped out more roles than the real event did. They say that the observed pattern has a probability of less than 1% to have just occurred by chance, so something else must have been going on. They also looked at what happened next. Over the next 66 million years, 12 new ecological roles appeared. For example, some animals learned to burrow deeply into the ocean floor and feed from the surface with tubes, basically the marine equivalent of working from home, but none of the new roles spread widely. They were just adopted by a few species each. The dominant roles today are those that already existed before the mass extinction. So contrary to the common narrative, the extinction didn't reset the system or open the gates to a completely new world. The authors put it this way: the extinction restructured but did not configure marine ecosystems. It increased pressure on all existing forms of life, but not in a functionally selective way. Instead, it reduced the population for all existing functions, but the existing functional diversity largely survived. That said, there is a warning in the details. because two of the roles did vanish. One was a type of clam that lived in symbiosis with algae. It extracted energy from the photosynthesis of the algae to build reefs. That role hasn't come back even after 66 million years, and no one's seen a podcasting clam for a while either. So while ecosystems can be surprisingly robust, if a functional role appears, it doesn't easily evolve again. It may be gone for good. Scientists warn we may currently be going through a sixth mass extinction, this one not caused by an asteroid but by us. But when we talk about biodiversity, we mostly talk about the number of species. This study suggests we should be asking instead what those species do, because the more ecological roles we lose, the harder it becomes for ecosystems to function. So if you're wondering what you can do to help ecosystems, start by preserving a variety of roles. And if you're a clam, it's time to start your own podcast. A nuclear fusion company claims they can create gold with a nuclear fusion power plant up to 3 tons a year. Really? Yes, really. Let's have a look. The idea comes from researchers at the company Marathon Fusion based in San Francisco. They're looking at the most widely pursued approach to nuclear fusion, that's deuterium-tritium in a tokamak device or similar. These devices have two big problems that the researchers say they can turn into an advantage. The first problem is that the reaction produces a lot of fast neutrons. These are very, very unhealthy, yet difficult to stop and require a lot of shielding. The second problem is where to get the tritium for the fusion reaction. Deuterium is an isotope of hydrogen with an extra neutron in the nucleus. It occurs naturally in about 1 in 6,000 hydrogen atoms and is also fairly easy to produce. Tritium is yet another isotope of hydrogen, this one with 3 nucleons. It basically doesn't occur naturally. It's produced as a byproduct in nuclear fission plants, but in incredibly small amounts. That makes it very expensive. Indeed, at $30,000 per gram, tritium is one of the most expensive substances on the planet, second only to coffee at Zurich Airport. These researchers now propose to put several layers of shielding around the reactor vessel so that the materials produce more tritium and also turn mercury to gold. In more detail, they have 3 layers. The first, the inner layer, contains a mix of mercury and lithium. The second, the middle layer, contains a molten salt of lithium, beryllium, and fluoride. And around the two, there's a shielding layer of a special type of steel. The neutrons that are created in the nuclear fusion are very fast. If they hit the mercury in the first layer, they do what's called an end-to-end process. That means the one neutron goes into the nucleus, but that kicks out 2 neutrons, leading to a net loss of 1. This turns the stable mercury isotope into an unstable one, which then decays into the normal stable isotope of gold. The middle layer with the molten salt slows down some of the neutrons. These slower neutrons are then captured by the lithium, which decays to helium plus tritium. They choose the amounts of these materials in the layers so that the tritium production covers the reactor needs, and then the other neutrons can be used to produce gold. They do a computer simulation for a tokamak with 1.5 gigawatt of power and say that it'd produce almost 3,000 kilograms of gold per year. At current market value, that's approximately as much as the value of the produced electricity. As they write, the consequence of this work is that the value of outputs of every DT fusion power plant is now around twice what they were expected to be, assuming the current price of gold. This will dramatically increase the amount of investment in fusion development and accelerate the deployment of economically viable fusion energy at scale. But there's a catch. It's that the freshly made gold includes a small amount of a radioactive isotope of gold. That means the gold will be radioactive for about 14 years until the radioactivity will drop below safety thresholds. I also have to warn you that this is not a peer-reviewed paper, but it all sounds roughly plausible. The question is, of course, how realistic the numbers from the simulation are. You may be wondering why not do the same thing with nuclear fission plants, since these also produce neutrons. The reason is that the neutrons are too slow. They don't lend themselves to this purpose. And why not just sell the tritium? Because the market is super small and it'd be saturated in about no time. CERN was recently in the headlines for producing gold in lead collisions at the Large Hadron Collider in the most recent run. But even summing up all the gold atoms they found, we're talking about picograms. So that's not going to finance their bigger collider. I think the idea of making gold with a nuclear fusion plant is cute. Basically alchemy, but with more computer simulations and fewer bits. I think we should call it solid-state capitalism. Africa's cracking. I don't mean this metaphorically. Rifts are opening as we speak, and a huge part of the continent is about to rip off and drift away, forming a new ocean basin, or so we thought, because thanks to a new study that just appeared, we now know not only just what's causing this, but we also have new clues for what's likely to happen next. Let's have a look. In northeastern Africa, 3 tectonic plates meet. There's the Arabian plate, the African plate, and the Somalian plate. The latter one is still in the process of trying to come into existence and declaring its independence. These plates meet roughly in the shape of a Y. The 2 upper arms have filled in with water already. That's the Red Sea and the Gulf of Aden, named after the city of Aden, though for Americans it'll soon be renamed to Gulf of where the hell even is this? But the north-south going trunk of the Y, so to speak, hasn't yet torn apart. It's called the main Ethiopian rift, and in geological terms it's due to open relatively soon, in 1 million years or so. Then a new ocean basin will form in what's now Ethiopia. And things are happening there, man, are they happening. For one thing, it's an active volcanic region with frequent eruptions. More remarkable, you can basically watch the ground rip open. Just 20 years ago, a crack appeared beside a volcano in northern Ethiopia and opened southeastwards for almost 60 kilometers. The sides pulled apart by up to 8 meters, and in some places the crack's 50 meters deep. Hundreds of goats and other farm animals were reported lost, but luckily there were no human fatalities. But while geoscientists are pretty sure that something dramatic's going to happen there in the next 1 million years or so, it's not clear what. You see, these 3 rifts are all pulling into different directions at different speeds, and it's hard to predict what stress relief on one rift will do to the others. The new crack, for example, actually doesn't belong to the main Ethiopian rift. It belongs to the Red Sea rift and goes towards the Gulf of Aden rift. A major factor of the uncertainty has been that geologists don't know what causes these rifts to form. One of the leading theories is that there's magma pushing up from deep within Earth, and that this heats and weakens the continental crust while also lifting it. Taken together, the weakening and lifting creates cracks. However, the magma might be rising and pushing just in one place or several places. Another idea says that's not what's going on, it's rather just tension caused by all these plates moving, which weakens the crust and magma rises up as a consequence of that, not the other way round. The authors of the new study now used new data from LAFA in these rifts and fed them into the latest seismic models of the upper mantle. They tested the competing scenarios for how well they fit the data, and they say that the best fit is the single mantle upwelling, that is a huge super plume of magma that pushes up against the crust and then spreads to the sides beneath the 3 rift arms. And they know where it is. They say that the push is the highest for the Red Sea rift and the Gulf of Aden rift. We already knew that these 2 rifts are opening faster than the main Ethiopian ridge. The one at the Red Sea and the Gulf of Aden open by about 2 centimeters a year, year, while the main Ethiopian ridge merely widens by about 5 millimeters a year, though that's still faster than progress in particle physics. The new study also supports previous findings that say that the crust under the main Ethiopian ridge is several kilometers thicker. And it now gives us a clue for why that is so. It's possibly because most of the pressure from that magma plume goes to the Red Sea and Gulf of Aden region. In the paper, they don't make a prediction for what's going to happen in the future, but my interpretation is that it speaks against the main Ethiopian rift opening quickly. So maybe Africa won't get a new ocean basin after all. Well, don't forget to come back for an update in a million years. Thanks for watching. See you tomorrow.